I worked on a new lab called Toxic by Hack the Box. We have this socket here with the IP address and the port. If I go over here, you will see a simple web page about a Dart frog with some info, some pictures, and buttons that don't work. They have anchors. They are taking us back to the top of the page. That's really what we have. If I go to the inspect module here and go to storage, I'll see the session ID. It is in PHP, so PHP session ID. Perfect. Now, if you look at the right-hand side for the data here, you will see that HTTP only false. This is a really important flag to look at. So let's talk about that HTTP only flag here. So HTTP only is a flag such that if it is true, if this flag is on, there is no way that client-side scripting is allowed. In this case, it is false, meaning that on the client side, on our end, we can inject scripts. Well, this is important. So it tells us what to do as a start to exploit this injection. Now, here on this download files section, I downloaded the files. Let me show them to you very quickly. It is in my Kali HTTP and then web toxic. Okay, I saved everything in this directory here. And if you look at the overall content, we have this Docker environment and the challenge files website. And then towards the end, we have some pictures and such. So it has altogether 8 directories, 40 files. Right. What I did is I put everything on my Visual Studio code, and I went through them. And what is interesting really for us is this index.php file, where it shows us that this PHP session ID with this cookie identifier here, it is decoded with base 64. And here, unserialization is something we can discuss very quick. Well, this process, serialization, is really in for storing or passing PHP values. It basically converts the byte stream or the data into string during this serialization process. So unserialization is basically changing or converting the string back to the data. This is what it does. Right? Now, let's look at this section part here where they do this decoding. So I can just get this PHP session ID, all right? And it is on the website here, that Dart frog here. I copy it, I get it from the storage and cookies back to the code, and that's the cookie. And remember, this is, let me show it one more time. Okay, that cookie will go through a decoding process. So let's do that. But or in order for us to decode it, we have to import this base 64 library. All right, and then let's call it cookie decoded, and we will do it by using this base 64 library, and we will decoding for base 64. So decode, all right, and then PHP session ID. So when we print it, let's print it. I'll be using a couple of different versions of cookies. So let's give a name. So let's call it original cookie decoded. That's without any change on the content as it is. It is cookie encoded. Perfect. Now, that's what you see. So this is the title of the book. So it is in a regular expression format, if I'm not wrong. It's in bytes format, and it has this regular expression details. In fact, it is in the index PHP while they do this cookie creation, page file, and the page name, and the procedure. So basically, when we decode the cookie, we see that our directory is www index HTML. Right? Now, it means that we can basically manipulate or present a malicious cookie where we change the directory. Before I go forward, let me talk about this 15 here. That's the number of characters. So from the double quotation here all the way to the second double quotation, we have 15 characters. Right? Now, we can be looking at other directories and which directory to look at. And based on what I've seen on the internet, so log poisoning is a feasible attack for this. So we need to reach to the log files. Now, in order to understand or to guess where the logs are stored, we really need to know about the web application behind this website, which software is used and where it saves the logs. That's the question for us to answer. Now, to answer this question, we can have an nmap scan. And let me get the socket here. So I just paste it. Okay, so this is the IP address and that's the port. So minus P, so dash P, that's the port address. Insert button is clicked. Okay, so it is here 31 252. All right, but in order for me to understand the script, the version of the script or used on the software and the name of the software, we need to add this dash sc and dash sv sv command. So dash sc is helping us to perform a nmap scan using the default set of scripts. And the SV is helping us to see the versions of the services running on that target machine. And if I run that here, if I'm not wrong, it should give a message because there you go. So it's the host is or the target is blocking our ping. So let's move out from this discovery phase. So let's add tech p n command. So that's okay for us because we know that this port is open already. Right? Now we should get the name of the service running on the web for the web hosting, and also the versions of the script. There it is. It is nginx. Right. So now we know that nginx is behind this website. Basically, it's the web server. Now we need to know where nginx saves the logs by default. And here we are hoping that the web developer didn't change the default directory for logging, which is a big mistake. So here by default, this is where the logs are saved. This is for nginx. It's just a quick web search. Now we know the software key for the web hosting, and also we know the typical directory for logs. We can try to exploit and we can change the cookie such that we can reach to that directory. So what I will do is show it here. I will paste it here first because I don't want to lose the directory here. So I will take this original cookie as a string in bytes format, right? I will replace the address directory with this inside the quotation marks, and I know I count that there are 25 characters here, so I change it to 25, and I can give it a new name called malicious cookie. Okay, that's how I will change the directory to that logs where the logs files are set. All right, I can go ahead and print it out. So print malicious cookie. Okay. All right, so the malicious cookie is this one. So I will reverse the process. So I will now encode it. And to do that, I can give a new name. Let's call it malicious cookie encoded. I'm using long names that are not necessary, but it's helping me to make sure that I'm following the routine that I had because I don't want to make a mistake here. It's a base 64 and base 64 encoding this time, right? That is base 64 encoding. There you go. Okay. And I will be encoding this malicious cookie. All right. And in fact, let me print this encoded malicious cookie. And that should be malicious cookie encoded. Awesome. Perfect. Now, you see this change here. The original cookie was this, and the cookie that we'll be using to reach the log files in this Nginx web web software, hosting web server software, let's call it. There's a change in here on the cookie. Okay, we got that. Now, I'll be using this web request on the Python. So let's go through this web request portion. So again, for that, I need to import the request library, which is pretty much what we need to send and receive data for the web. So URL that we are using should be HTTP. And let me get the address, right address. All right, this one. Okay. Now let's define this cookie as a dictionary. Now I'll be using this term PHP session ID as string. Okay, that's the key, and the value will be malicious cookie encoded here. All right. Now, if you pay attention to what we have here, this is in bytes format, and we will be inserting the cookie in a string format. So we will be using this decode, and I won't assign anything. So by default, it is doing this UTF-8 decoding. So basically here, that is decode the bytes using the UTF-8 for encoding, right? It's just the string output. All right, that's good. Now, regarding the headers, and the headers portion is important here because we will be putting together a library for this user agent part on the header, and this we will be trying to inject malicious codes to run commands on the directory where we are at, which will be the logs directory at the beginning. So for now, just to test, I can call it a test for the value of the key user and agent here in this headers dictionary. And finally, we go with this routine. So request, I will use R here. So we'll go this request menu, and we'll have this get request for this URL and cookies as we define as a dictionary, and headers with this test user agent value. All right, headers. That should work. Now I will go ahead and I will print the response in text format. That should work. All right, so we can give it a try, but to make sure that we are doing it right. So we are sending a web request on this URL, and as the cookie, we are using this malicious cookie that we have, right? So I will run it, and if you look at towards the end, let me clear the outputs and run all. You see this test. Okay, so that works. So we are now able to see the content of the logs file, and we have room here to inject the code to see the content. And in fact, if I will go to what I can do, alternatively, I can show that to you as well. Now I have this, hold on, let me go to Visual Studio. So now I have this new malicious cookie. I have it encoded. I can take it, copy it, and then go to the website. And here on the session ID, I can replace it with the new cookie and refresh the website. There you go. I'm reaching to the same content. You know, I've seen people doing the same thing using Burp Suite. You can use that too. I like Burp Suite. I like Python. I'm trying to learn Python, so I'm trying to use Python as much as I can on these challenges. Right. So that's perfect. So I have this test here. I will be using Visual Studio for the rest of the work. Now, instead of test here, let's copy it and paste it here and put it into the comment. Now we can try to inject codes instead of the test here. So we'll be using very simple PHP codes, right? So it's a string for us in here. So string comment. So we'll be inside a string here, question mark, PHP, and then I'll have this shell command using the system function and list, and I can list everything on this root directory. Then I close the parenthesis, it's a long list, semicolon, question mark, and then greater than symbol. I think that's all I have to use. Let's give it a try. It should give me the long list of the content on the root directory. Okay. Hold on. I'm making a mistake here. It's not really the root directory what I'm looking at. I'm just looking at the directory where I have the logs, right? So it should be the long list of the directory where I have the logs. Okay, you can check on the time here that I stopped the video and try to fix the problem, but apparently, or my understanding is that I had problems with my VPN connection here. No, here. I restarted my VPN connection and it starts working. So I don't really know if there was anything to do with this challenge or the code. It seems that VPN was the problem. Anyways, going back to the discussion we have, with this test, we were able to reach the log files and see that number 200s. So as the next step, I have it here. I won't type it. I will just uncomment it. That's the simple code injection for listing the content on this directory where we have the logs stored. So if I clear output and then run that, I think this is my previous run. Okay, there you go. Now it is giving us a long list of the content on this directory, and here we have this flag with some extension. Now, what we need to do is we need to go to that directory and read the file. Right? And for that, let me go up here. Now I will take this copy and paste it and then comment the first one. So now I will be having a new cookie. This time the directory will be dash flag, and then I have something. Let me copy it here. Control C. Okay, that's the so I have to count the number of characters. 11 from the two double quotes. All right. Now I have my new malicious code. I'll just rerun the code. It will generate a new encoded malicious cookie and place it in the get request and will give the flag. Nice. Well, I apologize for this earlier problem. I will look on that, but it seems that it is the VPN connection that was giving me the headache. All right, thanks for your time.